Okay, so now let's look at Windows exploits. So we're going to use Windows. You can use any version of Windows you like. And we're going to do this one, exploiting this vulnerable server on Windows. So you do have to adjust your Windows machine a bit. You turn off data execution prevention if you are on a server side of Windows, version of Windows, which has that on by default. And turn off the firewall. And you can enable error reporting. This isn't necessary, but it makes the error messages we're going to get a little more readable. And then you run this program called Vuln Server, which is open source, and you can modify it, but we're going to use the original version here. So I just download this thing and unzip it. And then you have in here two files, vulnserver.exe and essfunc.dil. It has a library it creates with the essential functions and the vuln server itself. And when you run it, it just starts listening. It's listening for client connections. Now, it's listening on the IP addresses of this machine. So if I open a command prompt and make the font big, and then do ipconfig, this is 192.168.11.30. So if I go to my Linux machine, and I can make this font bigger also. All right, I can do ping that. And I get replies, which proves that the network connection is good and that the firewall is off. And now I can do netcat to that address on the port 9999, which is the port used by Vuln Server. And now I get welcome to vulnerable server. And over here on the Windows machine, you see it's made a client connection to my other machine. So I can do things like help. And it has a variety of functions. And this is supposed to look sort of like an email server that has various functions. These are just meaningless functions, but they have vulnerabilities. And the one we're going to use is trun, which happens to have a simple buffer overflow. And that's the easiest. So for right now, I'm just going to exit. All right. And let me make this. Oh, that's right. I can't really make it any bigger. This will do. So let me go to my instructions. All right. So we test the server. We're able to connect. We're in business. So now we're going to fuzz it. Now I put a fuzzer on here. Let's look at that. Not listening to me. All right. Maybe the window is too big and I can't see it all. Yep, that's what's happening. Okay, good. Yes, Fuzzer is a program that sends unexpected data to servers. Usually you try sending random characters, special characters, and long strings. You just send random bits of data to a server over network connection to try to see if you can make it crash. It was originally discovered from people that used dial-up modems during lightning storms, which caused defects in the signal and caused programs to crash. So if you look at this one, this is the simplest possible fuzzer. This just sends a string of arbitrary length. So this makes a connection to the server with the IP address and the port. You get the length of the attack, and then it just sends that many capital A's. It sends a trun space dot, which is the format for this server, and then a bunch of A's, and then carriage return line feed. So the only thing this fuzzer does is check for length. So it's checking for buffer overflows. Other fuzzers will be smarter, and they will try using large values and negative values in numerical fields and things like that. But fuzzing is the general principle of sending random junk to a server to try to make it crash. So if I run this and I send 10 A's, it works and it says goodbye, it didn't crash. So if I try 100, it still works and says goodbye. So I try 1,000. and it still works. So I try 10,000 and it crashed. It didn't come back. It couldn't handle 10,000. So if I look on my Windows machine, it has crashed. The Vuln server has stopped working. So that's informative. So I'll close the program and I'll restart it. Got various windows to close here. All right, double click it. It's restarted. All right, so somewhere between 1,000 and 10,000, there's a crash. So if I give it 2,000, it crashes. So this has some kind of defect. I don't know yet exactly what kind of defect it is, but it does have some kind of denial of service defect that I can trigger with a 2,000 length string. So let me go to my instructions. All right, so the way you do it, now remember we did this on Linux. To understand why it crashed, you use a debugger. And on Windows, we're going to use the Immunity Debugger, which is a free, powerful debugger, commonly used. And so in the debugger, did I already have the program listening? I think I might, in which case I'm going to close it because I want to run it inside here. Nope, it's not already running. Good. So inside here, I'm just going to open that program with file, and it's down here in downloads Vuln server. Now, when you load a program in the Immunity Debugger, it shows you a baffling bunch of information, and you want to get used to this. In general, there's a simple rule for all these reverse analysis tools, reverse engineering tools. They're designed for experts. So they put the most complicated, detailed stuff where it's easy to see. And for beginners, they put that down in the corner. So the only thing that matters to us right now is down here in the corner, paused. The program is not running. You have to hit the run button here to make it run. Now it's running, listening. Anyway, now let me talk about these windows. Well, first, let's fuzz it. So I'll send this fuzzer. I'll send that 2,000 that makes it crash. And okay, it crashed. And now I can say, again, ignore all this complicated stuff. It's paused now. And if you look at the bottom, it will tell you what went wrong, although sometimes it vanishes and you have to view the log by going view log. All right. And the log says access violation when writing to 41414141. So it tried to write to that address, which is the A's. So this is something, this crash does cause the program to crash, but I do not gain control of the instruction pointer. Instead, I control a write operation. Now you can take over a server with just a write operation, but it's more complicated. So I've learned the important thing I wanted to know, which is that this crash is going to be a little bit complicated to exploit. So I'm going to do debug, restart the server. And it's paused again, so I have to run it again. Now I'm going to try sending 3,000 because 2,000 is a crash, but it's not the crash that's easiest to exploit. 3,000 causes it to crash. And now if you look at the bottom, you'll see access violation when executing 41414141. And you can also see that by viewing the log. So now I gain control of the instruction pointer. And this is what I was saying earlier. In more complicated situations, you have to be careful to keep the length of your attack string the same. Now I know that a length of 3,000 will hit a bug that is easy to exploit, where some of those A's control the instruction pointer. That's the one I want to use. So I have to go back to my Debian machine and up to the instructions here, because I have to have this code inside here so I can copy it. All right, so that was my fuzzing. I found out that 3,000 is a good crash that will be pretty easy to install, to exploit, and that's what I want to do. So now I should probably talk about the immunity window. We'll do it in the next step after we do this. All right. The only part we've used so far is the paused button in the right-hand corner and the message at the bottom, but that's enough to get what we need here. Now, all right, we sent 3,000 days, we saw it, we restarted. Okay, now what we want to do is create a non-repeating pattern of characters. So I'm going to call this thing VSEIP0. There is a Metasploit tool that does this too, but I don't see any reason to use it when I can just write it in Python. Nano VSEIP0. All right, and escape Y will get rid of the colors. Okay, this runs Python 3. All it does is for I in 0, 1, 2, 3, 4, and for J and K in any digit, it will then print a 3-digit number and then a capital A. And it will do that 500 times. So let's just see how this looks. I save this, make it executable. And then run it. All right, and this is what it looks like. 274A, 275A, 276A, up to 499A. So it makes 2,000 bytes of data, 500 groups of 4 bytes. And the point is, any 4-byte sequence here is unique. I can find it. So that's enough information. Now I need to make, I need to include that in my exploit. It's the first time I sent 3,000 A's and it crashes. Now I want to send 1,000 A's followed by that 2,000 byte non-repeating pattern. So that's what this one does. And I want to call this VSEIP1. I'm trying to find out which bytes control the instruction pointer. So I nano VSEIP1. All right. And one thing I have to do is correct the IP address. It's 192.168.11.30 for this system. That should do it. So it's going to send 1,000 A's, and then it's going to send that 2,000 non-repeating bytes. So the prefix is 1,000 A's. The characters are the 2,000 bytes. And this is how you send it in Python 3. You encode it as Latin 1. And then you send it this way. So you're sending a byte array, by the way, a byte in Python 3, not a string containing non-printable characters, but you use a byte array to do it. So I save this. I go back to my Windows to make sure that my thing is loaded and running. It's paused, so I better restart it with debug, restart. All right, now it's reloaded. Now I have to run it again. So it's no longer paused. Now it's ready. And now I can send that attack, VSEIP1. And, oh, I forgot to make it executable. chmod +X VSEIP1. All right, there. So it sends that. And the server crashes. And now I see where it crashed. 31, 41, 32, 35, reading right to left. So that is 1A25. And if I go to my instructions, I think that's what I expected. Let's see. The 35, 32, 41, 31, that's what I got. So I can find that in my non-repeating pattern, and I've got a picture here of finding it. That's 52A1. And there it is. 52A1. So I now know which of those bytes I sent up ended up in the instruction pointer, and I can make a more precise target. So that's this one, VSEIP2. All right. I got to fix the address. All right. And so now I figured by counting it through, I figured out it was 2006 A's, then BCDE should hit the instruction pointer. And then I just put in enough F's to make the total length 3000. And that's my attack. So let's see if that works. If this works, I should get BCDE in the instruction pointer. So I change mode +X. And then I restart it here with debug, restart, and run it again. And now I run that attack. Didn't hit my slash dot correctly. Okay. There, that sends. And the server crashes and executing 45, 44, 43, 42. So now I know exactly where the instruction pointer is. So I know you people have a break at 3. It may not be worth doing all the demonstrations live from this point. I think I can just talk about the remaining steps, which should be familiar because it's what we just did on Linux. So now I have control of the instruction pointer. So I just have to inject code from Metasploit and then jump into the code. And it looks a little different on Windows, but you can do it here. So I get the EIP precisely. All right. And I think I will demonstrate some more of this, but I'll just make it a second part after your 3 o'clock break. This is enough to get started. I'm going to stop this one.